Hi everyone, welcome to our second part of chapter 9 tutorial. Now today what we're going to do now is the calculation about layout decision. But first of all, I want to emphasize that all the calculations that we'll be doing in this part here are calculations that are based only on the process oriented layout. It's not applicable in the warehouse layout, office layout, and so on. These calculations are based only on a process oriented layout. So the first question that we'll be doing is about the layout decision MPC project company. Now it says that you have been hired as director of operation at MPC project company, which is MPC. It is a machine shop. Now MPC is planning to move to a new location. The company has 6 departments, whereby we have the material, the welding, the drills, the lathe, the grinders, as well as the benders. Now the new building has 6 distinct rooms, roughly equal in size. Now your employer, Mrs. MPC, feels strongly about safety and intends to have a marked pathway throughout the building to facilitate movement of people and material. Now the building schematic is provided below. So this is the building schematic that is provided for this case study here. This building schematic just means that this is the building of the company itself, and that building has 6 rooms. We have room 1, 2, 3, 4, 5, and 6. Now they gave us the distance between rooms, so we have the distance between 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. I say that the distance is 5 meters, and we have the same from 1, 3, 1, 6 to 5, 4, 6, and the distance is 10 meters. So everything that is given here are the distance between rooms. Now it also mentioned that please note that the above figures represent distances in both directions, meaning from 1 to 2 and vice versa. Now the company foreman, Mr. Kalala, has completed a month. We are on this paragraph here. The company foreman, Mr. Kalala, has completed a month-long study of the number of load of material that move from one process to another in the current building. Now the information showing the flow of semi-finished component in terms of load moving from one department to another is given below. So they tell us that they have 6 departments, and this is the load that is moving from one department to another. For example, the first one is from material. There are 25 load that move to welding, 20 that move to lathe, 15 that move to grinder, and 3 that move to the bender, and so on and so on. These are the movement or the number of units that move from one department to another. Now it says that you are required, because you recently graduated from the University of Johannesburg with a specialization in operational management. Now Mrs. MPC would like you to compare 2 allocation she is thinking to implement the building. So we have 2 allocation. The first allocation, it says that in room 1 we should allocate M, which stands for material. In room 2 we should allocate W, which stands for welding. Room 3 we have the drill. Room 4 we have the lathe. Room 5 we have the grinders, and room 6 we have the benders. So they say that material in room 1 and so on. This is the new allocation that is given. Now we also have the second allocation. Now the question that is asked is to propose which allocation is the best. How do we do it? So we should calculate the total handling cost for each and every allocation that is given in this case here. So we start first of all by calculating for the first allocation, and after we'll do for the second allocation. So this is the first allocation, and the first allocation is saying that we must have a material in room 1 and so on and so on and so on. So what we need to do first of all is from here, this is the first allocation itself. This is how the company would like to allocate the department, like this. So it's more like in room 1 we have the material, in room 2 we have the welding, in room 3 we have the drilling, in room 4 we have the lathes, in room 5 we have the green, in room 6 we have the benders, and so on. So this is how it looks like. So now what is left? For the first thing that we need to do is to do the distance matrix. This distance matrix is going to tell us what are the distances between one department to another department. And now in this case we have 6 departments. So this is the distance from 2, and we have room 1, 2, 3, 4, 5, 6, and then we have 1 2 3 4 5, and we have the last one, which is 6. Now from here we need to allocate. First of all, we should know that because our distances, there's no distance that are between the same department. So that means between department 1 and 1, the distance, there's nothing that we can put here. So we just put dash between 1 and 1, 2 and 2, 3 and 3, and so on. Now what we're supposed to do here, they're saying that the distance between room based on the above schematic is as follows. So they say that the distance between 1 and 2, 2 and 3, 3 and 4, 4 and 5, 5 and 6 is 5. So the first thing that we do is the distance between 1 and 2 is 5, 2 and 3 5, 3 and 4 5, 4 and 5 5 again, and 4 5 and 6 is 5. Now this is the first part that we have completed, this one here. So let me just highlight it in blue to show that we have already used it. Now we are on the second part. The second part that is saying the distance between 1 and 3, 1 and 6, 2 and 5, 4 and 6, the distance is 10 meters. So we have 1 and 3. So the distance between 1 and 3, it says that is 10. Next, the distance between 1 and 6 is 10 too. So here the distance between 1 and 6, here we have another 10. And then the distance between 2 and 5, it's 10 too. So 2 and 5 is here, we have a 10. And the distance between 4 and 6, the distance is 10 again. The distance between 4 and 6, it's somewhere here, and the distance is 10. So we have completed the second row of distances. Now the third one is the distance between 1 and 4. 1 and 4, it says that the distance is 20. So 1 and 4, the distance is 20 here. Next, they say the distance between 3 and 6 is 22. So 3 and 6, it's somewhere here, the distance is 20. Now we are also done with this row. The other one is the distance between 2 and 4, 3 and 5, the distance is 7. So the distance between 2 and 4 is 7. 2 and 4, the distance is 7. Next is the distance between 3 and 5, and the distance is 7 again. 3 and 5 is here, the distance is 7. And next we have, so we're done with this row too. You can highlight it so that you're not confused. The last one now is the distance between 1 and 5, 2 and 6. 1 and 5 is 16. So we have 1 and 5. The distance is 15. And we have 2 and 6, and the distance is 15 too. So we have 2 and 6, the distance is 15 too. Now because now we're done about the we're done with our allocation from here. But now because of this statement that is saying that, please note that the above figures represent the distance in both directions. So it means that the distance between 1 and 2 is equal to the distance between 2 and 1. So we need to fill the rest of the table. Like here, if the distance between 1 and 2 is 5, that means the distance between 2 and 1 will still be 5 here. Same applies for 3 and 1, it will be 10. And then after 10 we have 20, and then we have 15. After 15 we have 10. So same applies for the distance between 2 and 3. It says that it must be 5 too. So we have 5 here, 7, 10, and we have 15 here. This is the 15, the distance between 6 and 2, which is 15, and we have 2 and 6, which is still 15. Now here we are working for the distance between 3 and 4. 3 and 4, the distance used to be 5. That means 4 and 3 will still be 5, 7, and then we have 20 here. 5, 7, 20. Yeah. Now the distance between 5 and 4 is the same distance as 4 and 5, which is 5. That means we'll have 5 here, and then we'll have a 10 here. And finally, the distance between 5 and 6 is 5. That means the distance between 6 and 5 will still be 5. So we're done with our first part about the distance metric. Now the second thing that we need to do is to draw the flow matrix. The flow matrix will show us how many units are moving from one department to another. Remember that this one here, the distance matrix, it shows us the distance between department, distance between rooms. while the flow metric here, it shows us the number of unit, the number of moving unit from one department to another. So the flow metric, as I say, it shows us how many units are moving from this department to this other department. So in short, we can still keep the same table here, but we just change the content. But now we have 6 departments too, according to what is said, and these 6 departments are given here. We have they're given already at the beginning here. These are the 6 departments: the material, the welding, and the benders. These are our department. So the first one is material. After material, we have drills, lathe, and so on. So in one, we have material. After material, what do we have? After material, we have welding and drills. So we have welding, and here we have drills, and after we have lathe, welding, drills, lathe, and then we have grinders, and lastly benders. So we have grinders here, and then we have benders, which is the last one. So we do the same for the material. For the columns, we put the same heading as a row. We have drills. After drills, we have the lathe. After the lathe, we have the grind, and finally we have the benders. Now it's the same principle that applies. There are no materials that are moving inside the same department, so there's nothing moving from material to material, welding to welding, drills to drills, lathe to lathe, grind to grind, and then we have bend here. So yeah, green. Yeah, so the next thing that we need to do now is to allocate the number of units that are moving according to the problem. So now we are working from this row here. It says that from material there are 25 that move to welding. So from material we have 25 that move to welding. After the 25 we have 20 that move to lathe. So we have 20 here, and after the 20 we have 15 that goes to the grinder and 3 to the benders. So we have 15 to the grinders and 3 to the benders. So we have 15 grinders and 3 benders. 15 grinders and 3 benders, yeah. So from here, what we do again, we highlight this part just for us not to be confused. We can highlight it in blue again. Now we are working on this. So here, this one is from the welding. We have 6 that are moving to material. So from welding we have 6 that are moving to material, and then we have the 6 that are moving to material, and then we have 42 that move to drill. 42 that are moving to drill, and after the 42 we have 12 that are going to the grinders. So the grinders here we have 12. Yeah, that's it about the welding. Welding we have 6 that goes to material, and after we have 42 that goes to the drills, and then we have 12 that goes to the grinders. Okay, so we're done with this one too. Now we are working for the drills. When it comes to the drills, it says that we have 12 that are moving to the welding. So we have 12, the drills here we have 12 that are moving to the welding. Yeah, 12 that move to the welding, 5 that go to the left, and 38 to the benders. So we have 5 here, and then benders we have 38. So it says that we have 12 that move to the welding, and after we have 5 that move to the left, and then we have 38 that move to the benders. Perfect. Now we done also with this one here, so we highlight it. Now the other one is about from left we have 4 that move to material. From left here we have 4 that move to material. After those 4 we have 12 that are going to the welding. So welding we have 12 again here. Yeah, we have 4 that goes to the material, 12 to the welding, and then we have 20 to the grinders. Grinders it's here, we have 20, and after the 20 we have 11 that are going to the bender. So we have 11 that are going to the bender here. Also, we're done with this part, so we can highlight it. Now we are working on this row here. Now from grinders, we have 5 that are moving to material. So from grinder here, we have 5 that are moving to material, and after those 5, we have 15 that are moving to welding. So we have our welding here, which gives us 15. Grinder and welding is 15 here. And then we have from grinder, we have 3 that are moving to drills. So we have our drills here, we have 3 of them. We have 3 that moves to drill and 25 that are going to the bender. And then we have 25 that are going to the bender here. And then from the bender, that is what we're working on here. From bender, we also done with this part here, so we can highlight it. We are working now the last dot here. So from bender, we have 4 loads that goes to material. From bender, we have 4 loads that goes to material, and after the ones that are going to material, we have 2 that are moving to welding. We have 2 here, and after those 2, we have 13 that are moving to the drill, and then we have 13 here, and after those 13 that are moving to the drill, we have 20 that moves to the left here. We have 20, and after the 20, we have 12 that are going to the grinder. So we have 12 here. So let me just check. From bender, we have 4 that goes to material, and after we have 2 that are moving to the welding, and after we have 13 that are going to the drill, 20 to the left, and then we have 12 to the grinder. Yeah, we're done with the allocation. We're done with the flow of unit. So now we need to solve. We need to solve based on this allocation here. This is what they're telling us. So now that we have the distance and the flow metric, now we can solve. Let's go to a new page. Now the solution will be based first of all on the allocation based on the distances. How did they allocate? According to the allocation that we have, this is the distance flow metric. We'll be working from this one here. Now based on the allocation that we have, it says that in room 1 we have the material, in room 2 we have the welding, in room 3 we have the drilling, room 4 we have the left, room 5 the green, and room 6 the bender. So that means material will be here we have the material that will be in room 1, and then we have the welding in room 2. We have the welding in room 2, and after the welding we have the drills and the lathe. So we have drills here in room 3, and then we have the lathe in room 4, and after the lathe we have the green and the bender finally. So we have green and bender here. So we do the same for the columns. We have the material here. After material we have the welding here. After the welding we have the drill, and after the drill we have the lathe, and then we have the grinders, and after the grinders we have the bender here. Now from here we can start working. We can start with our calculation. The first thing that we'll be doing, we work first of all for row 1. Row 1 will be our row here based on the table. The row 1, it is based that it assumes that in room 1 we have the material, but what is the distance between room 1 and room 2? We are not working from room 1 and room 1 because it's the same room in short. So here we have room 1 and room 2. What is the distance? The distance is 5. But now, what is the department that is in room 1? Is the material and welding. Now, how many units are moving from material to welding? We look at our table. Material is here and welding is here. So we have 25 units that are moving. So we have 25 here. Plus, we do the same thing here. Which room are we working on? We are working with room 1 and room 3. Number of units is, the distance is 10. How many units move from material to drill? Material to drill, we are here. and drill it somewhere here. By the way, I forgot to mention that all these empty cells, when it comes to the flow matrix, there's nothing that is moving, so we have 0 in all the empty cells. We have 0 here, another value of 0, 0, 0, 0, and 0. So we were working for room 2, we are working for material which is in room 1 and room 3. The distance is 10, but how many material move from the material to the drill? So we have material here and the drill. That means the distance, there's nothing, we have a 0 here. Plus, now we are working for room 1 and room 4. The distance is 20, but how many units are moving now for the material to the left? So we go to material and left, we have 20 units. We have our 20 units here again. Plus, now you're working with the green. It's room 1 and room 5. The distance is 15. How many units are moving from material to the grinders? So we have material here and the grinders, which gives us 15 too. So we have a value of 15 here. Plus, and then we have material and bender. So we have material and bender. The distance is the distance between room 1 and room 6, which is 10. And then material and bender, how many units? Yeah, here material and bender, we have 3 units. Times 3. And then here we have row 2. Now row 2, we'll do the calculation for all the rows when we're done. So row 2 is here. Based on row 2, we are working now on unit. We are working row 2 is from room 2, as we can say. So we have room 2 here and room 1. The distance between them is 5. And then how many units are moving from the welding to material? We look at our table. We have welding and material. We have 6 units that are moving, welding and material. So we have 6 units here. Plus, then we're supposed to check welding, and welding is the same department, so we skip to welding and drilling. So welding is room 2, and drill is room 3. So they are meeting somewhere here. And the distance is 5. The distance is 5 here. Yeah, so you have welding and drilling, the distance is 5. How many material now are moving from welding and drilling? The material of it's 42. So we have 5 times 42 here. Plus, here we are working for room 2 and the lathe here. So that means the distance is 7. So we have welding and lathe. Welding here and lathe, it's 0. So we have our value of 0 here. Plus, we do the same thing for the welding and the grind, which is room 2 and room 5. Room 2 and room 5, the distance is 10. This is our 10 that we multiply by welding here and grinder. So we go and check again welding. Where's welding? We have welding and grinder. The distance, we have 12 units. So we have our 12 units that are here. Plus, then we do room 6, room 2 and room 6, it's 15, the distance. So we have 15 that we multiply by welding and bender. How many? Welding and bender, we have nothing here. Bender is somewhere here. So that means it's 0. We have a value of 0. Again, we'll do the calculation later. So we have row 3 now. From row 3, we have the distance between room 1 and room 3 here. The distance is 10. We have a distance of 10 here. And how many units are moving now from the drills to the material? Go here, we check drills and material. We have nothing, it's 0 units. So we multiply by 0. Plus, we open again. This one now will be room 3 and room 2. Room 2, the distance is 5. How many units are moving from the drills to the welding? We have drills and welding here. The unit, we have 12 units. So we have 12 plus. Then from here, we are not working drills and drill. We work now drill and lathe, which is room 3 and room 4. The distance is 5. And then from the drills and the lathe here, how many units are moving? Drills here, lathe here. So we have 5 units that are moving. So we have 5 times 5 plus. Then we work for the lathe and the grinder, which is room 3 and room 7 and room 5. The distance is 7. How many units are moving from the drills to the grind? So we have drills here and grind, it's 0. There's nothing that is moving. So we have a value of 0. Plus here room 3 and room 6. Room 6, the distance is 12. But room 6 is the bender. So we are checking the distance between the drills and the bender. We have drills here and the benders, which is 38. So we have our value of 38 here. And we have room 4. Now room 4 is the distance between room 4 and room 1, which is 20. That we multiply by what is the distance between the lathe, how many units are moving from the lathe and the material. So we go back, we look for lathe and material here. So it's 4 units that are moving. So we have our 4 unit here. Plus, now what is the distance between room 4 and room 2, which is the lathe and welding? Now we have 7. And then lathe and welding, how many units are moving from lathe and welding? We have 12 units that are moving. So we have 12 here. Plus, you open a bracket, and then this one is room 3 and room 4 and room 4 and room 3. So we have 5. That is the distance. The unit that move from the lathe to the drill. Go back and we check lathe here and the drill. We have 0. Plus. Now we are not doing room 4 and room 4. We do room 4 and room 5. The distance is 5 again. And now how many units are moving from the lathe to the grind? So we go back here, lathe and grind. We have 20 units that are moving. So we have our 20 unit here. Plus, we are doing lathe and grind. That means we'll be doing now lathe and bend. The distance is 10 between room 4 and room 6. So we have lathe and bend. Lathe and bend is somewhere here. Lathe and bend. So we have 11 units that are moving. So we have our 11 units that are here. Then we have row 5. Row 5 is the distance between room 5 and room 1. The first one is the distance is 15. That we multiply by grinder and material. So we have grinder and material. We have 5 units that are moving. And then we have our 5 units plus. Then we have grinder and welding. The distance is 10. And from the 10 we have grinder and welding. So we look at our grinder and our welding. We have 15. So that means we have our value of 15 here. Plus we are working for grinder and welding. So now with grind and drills, which is room 5 and 3, and the distance is 7. That we multiply by grind and drill. So we have grind here and drill here. That means it's 3. Our value of 3 here. Plus now it's the distance between room 5 and room 4. The distance is 5, and room 5 is the grind, while room 4 is the left. So we look at the grind and left. The distance is 0. There's nothing here. So we have 0. Sorry, I mean the number of units. Plus this one will give us the distance between grind and grind, which we don't calculate. So we need to calculate from 5 and 6, and the distance is 5. How many units are moving from the grinder to the bender? So we have grinder here, and then we have bender, which gives us 25. So we have a value of 25 here. And then finally we have row 6. Row 6 is telling us the distance between room 6 and room 1. So we'll have 6 that we multiply. Oh sorry, we have room 6 and room 1. The distance is 10. That we multiply by the number of units between bender and material. So we have bender and material here. The number of units is 4. So we have 4 units here. Plus now with bender and welding, which is room 6 and room 2. We have 15 units that are moving, but now we have 15 meters between the two rooms. How many units are moving now between bender and welding? So we have bender and welding. The number of units that are moving, it's only 2, so we have 2 here, plus bender and drill, which is 6 and 3, the distance is 20. That we multiply by 6, bender and drill, 20. So we look at bender here and drill, we have 13. That means you have 13 units here, plus now it's room 6 and room 4, which gives us 10. That we multiply by bender and lathe. Bender and lathe it here. The number of units that are moving is 20, so we have 20 here. And then we have with room 6 and room 5, we have 5 units that are moving. And from these 5 units, the distance is 5 between 6 and 5, between room 6 and room 5. So now we check from bender and grind. How many units are moving from bender and grind? We have 12 units. So we have our value of 12 units here. Then we should now do our calculation to compare our answers. We should do the calculation first of all to find the rooms. What is the value from each room? So now from the calculation that we have, that if we need to do for row 1, we get a value of 780. This is for the first room. The second room, we get our value of 360. The third one, we get a value of 845. The fourth row, we get a value of 374. And room 5, we get a value of 371. And room 6, we get a value of 590. By the way, the values that we get here are in rand. They are telling us what is the transportation cost for each row. Now what we need to do is to do the total material handling cost. So from here we just need to add all the values: 780 plus 360 plus 845 plus 375 plus 371 plus 590. And the value that we get is 3000 here, 320. This is the total. In short, this is the handling cost for this allocation here. It means that if we need to use that allocation, the company must be expecting total handling cost of 3,320. In short, that's it about this part here of the first allocation. The following video will be now based on the second allocation. Thank you so much for your time.